Welcome to Module 4 of Input-Output Analysis, where we talk a little bit about production functions in input-output modeling. This is kind of an excursus because if you think of production functions in economics, this is something you've heard of in Econ 101, where you looked into different production functions, what I mean. Production functions are a way to capture how inputs transform into outputs in a specific firm or sector. So quite often they hide all the production process. You have all the inputs coming in, black box, some good is produced of it. And you probably have encountered several types of production functions before. For example, you might be familiar with the Cobb-Douglas function, linear production functions, Leontief production functions. And here this might ring a bell, looking back to the last videos, where input-output modeling depends on the work of Leontief, and also an activity analysis production function, which you perhaps have not heard because it's something you not encounter in economics quite often. The Cobb-Douglas function is the total output as the result of a total factor productivity in capital and a multiplication with labor. And we have the elasticity of capital and labor, so how easily they can be replaced with other capital or other labor in order to produce a specific output. This is what we mostly see in neoclassical economics, where we assume Cobb-Douglas production functions with all their advantages and disadvantages. Linear production functions are a little bit different. Here we have capital and labor as input factors, which are perfectly substitutable between specific or different inputs. So you have 50 capital and 20 labor, and there is some efficiency in the production process, which gives you 10 outputs. This is what A and B gives you, telling you how much capital is used to produce one good of output. Leontief production functions are exactly the case as in the Leontief input-output tables. We have the input, because we have again the input factors capital and labor. But in the input-output table, as you've seen in the last videos, the proportion of production functions are constant. So there is always a specific proportion of input from sector 1, from sector 2, and from sector 3 to produce goods in sector 1. This does not change. There is no possibility for change in the production function. And this is why we have this minimum sign here, to say like, okay, this input relationship is the one that actually determines the output. There is no substitution between different input factors. And this is where the activity analysis production function comes in. It looks quite similar to the Leontief production functions, and the reason for that is because it is actually a variation of the Leontief production function. It includes a resource constraint, which also makes it extremely interesting case if we have limited resources, like in a real-life economy. We cannot exploit the planet until infinity with resources. All resources are limited and constrained, and so an activity analysis production can capture that. We have, again, capital and labor as input factors, but due to the different formatting and the resource constraint, we have actually, to a specific amount, we can subsidize between different input factors. One way how to visualize that has been done in the Miller and Blair book that I recommended you. And I show you this graph here because it's really brilliant. They capture all those 4 production functions, plot them, and show you to them. And on the top left, you have the linear production function. You just move from one input factor to the other. You have linear subsidiarity. In the top right, you have the Cobb-Douglas production functions with its characteristic curve. They will asymptotically arrange to the x-axis and the y-axis, and they will never be satisfied. You have infinite amount of production here. The Leontief production function in the bottom left, you have this L form where you always produce in the corner of this L. If you move in a different direction. You cannot produce more of that good because the minimum inputs of the other input factor are lacking. And this is where the activity analysis production function comes in. It looks like a little bit a Cobb-Douglas function, but more linear. And this is the beauty here. Because we are suddenly in a range where we shift a little bit, where we assume perfect substitutability, and beyond that, we run into problems. And it's also interesting to see that if you want, you can also write the Cobb-Douglas function in a Leontief form, or the other way around actually. The Leontief production function is a corner solution to the Cobb-Douglas function. And therefore, the activity analysis production function is also a variation of the Cobb-Douglas function, just as a step function and more linear. So these are different ways how you can incorporate a production function to model economic activity in an input-output table. Keep in mind, the moment you divert from the traditional Leontief production function, things get more difficult because you have to apply different mathematical frameworks to the input factors.